Thank you very much, John. 14 years. Oh, I'm slowly realising I've become a career civil servant. I joined the Home Office back in 2004 and also joined the Government Operational Research Society. I've been at the Home Office on and off since then in a wide range of jobs covering police performance, crime statistics, OR kind of modelling for border force and for drug-related offending. But for the last year and a half, I've been the head of data science in our data analytics capability centre. What I'm going to cover in my slot is just kind of a bit of context around analytics and data science in the Home Office. Talk through a bit of the kind of foundational capabilities that we've built that support our work in the lab. And I'll talk about a couple of case studies where we're using machine learning to support our operational colleagues around the department, and then kind of wrap up with a few reflections on how we do data science in government. If I can click through, yes. So the Home Office, obviously a very large government department, £11 billion annual budget, thereabouts, although a lot of that kind of comes in one door and straight out another in the police grants. Nearly 30,000 employees, so lots of operational staff at the border, caseworking, and all delivering our four kind of headline objectives around terrorism, cutting crime, controlling immigration, and also promoting growth. Within the central Home Office, the big kind of operational delivery arms cover crime policing, fire, and visas, immigration enforcement, border force, so actually at the UK border, passports, and terrorism. But we also have relationships with these arm's length bodies, more on the kind of public protection side, so police, fire, and security service. And data science within the Home Office, so we have a team of about 30 data scientists now. We all work in the Data Analytics Competency Centre, which is our secure lab, which has been built to support data science and supporting data science to transform our operational businesses in the department. That means we're quite fortunate in that we've got our kind of dedicated network and we have the access to the software and tools we need. And we've also done a lot of investment on the data engineering side to make sure that the data is there and ready for exploitation for analysis. We sit within a kind of dual reporting structure, so although the team is embedded within the analysis and insight function of the Home Office, which means we're associated with all the professional analysts in the department, we also report into the digital data technology side of the department too. Which on the one hand means twice as many management meetings, but it also means that we are working side by side with the digital colleagues that we need to really deliver data science and have an operational impact. So we're working in the lab alongside the architects, the people who are responsible for maintaining our systems, the people who are responsible for obtaining data and getting it into that form where it's kind of primed for use for analysis. We're largely business driven, so we work on a commission basis, delivering projects for customers around the department, but we also try and create space for innovation to kind of identify those approaches that are going to be the products we can sell to our customers in the future. Just to talk a bit about that kind of foundational services that we rely on to deliver most of the products that we develop in the lab, specifically around data. So I mentioned that we've got data primed for use for analysis, and there are kind of two main arms to this. The first is unifying our data structures. Now, the Home Office, like a lot of government departments, has got lots and lots of legacy data systems. Would have been designed to be fit for purpose at the time, but now how do we take those systems, the data residing in those systems, and expose them for use for analysis? It's perhaps a particular issue for the Home Office, where we're, in the example of immigration, for instance, we're often dealing with individuals who've had a very long series of engagements with the department, stretching over decades, and we need to be able to draw on all of that data, really, to use analytics to provide services to them. So on the left-hand side here is just sketching out how we can form all of those different data sets to a single structure that we can then use for analysis. So we call this the pole model: person, object, location, and event. And this is really about just pulling out those entities from different data systems that we ingest, and identifying those kind of common entities across them, and indeed within them. So some of these legacy systems will be designed on a kind of case basis rather than a person basis. So what I mean by that is that, for instance, our passports database, the key entity there is a passport document. Within the system itself, there's nothing to link together an individual across all of the passports we may have issued them over the decades. So this model is trying to accommodate that. And the second arm of it, which is absolutely vital to us, is doing universal matching across these data sets. We do matching once to support multiple applications. And we use probabilistic matching here because we don't have unique identifiers across all of these legacy data sets, or we're lucky if we do. Thinking still about how we manage data, we brought all the data together, but we still have a really strong focus on data governance, making sure that we have the right permissions and consents in place for using data for each specific project we do. But this is a huge enabler to switch it that way around. Get the data together first, and make sure you have strict controls around the governance of that, rather than vice versa, go through the long discussion about governance and then start on the technical changes you need to get that data in place. We'll talk a bit more about matching. We use a commercial product called IBM Infosphere to support us in this. So the processes we step through, we take all of this data from legacy systems, we standardize it, and so within here we're talking about getting rid of unnecessary punctuation, changing the cases, getting it into cleaning up the data somewhat. We then need to bucket it together, so this is really about just making sure that we are making this calculation kind of tractable by bucketing all of our different entities where we think there's an element of similarity. So pulling out the consonants of names, for instance. So we've got buckets that we can search for possible matches within. And then we use a probabilistic method that takes account of edit distances, so we can kind of accommodate for typos. We have dictionaries of commonly alternating names and so forth. And we use this across all of the identifiers that we might have in a data set, so we can execute it across name, telephone number, email addresses, et cetera, to come up with a score for each of those comparisons and build up a consolidated score across a person. But we're also looking at doing the same for locations, for events, for objects. Objects would be something like a passport or another document. And then once we've got these scores about kind of pairwise comparisons between different entities, we can start combining those to get a single view of a person, we call it. So even though in this example at the bottom here, John Smith and Steve Black, if you just had those left and right records, you're unlikely to associate those two together. But because within our data we've got an additional data set which identifies Steve Black as a known alias for that person, we can join all three of these records together to get that single view of a person. And recall that a lot of our data does stretch over multiple years, so changes of name, changes of address, phone number, these are common. So it's important that we can build this consistent view across the entirety of a person's data with us. Sorry, a bit of a delay on my click here. Okay. Okay, so we have these entities linked, we have scores as giving us an indication of the strength or the probability that these are indeed associated records. We then need to set thresholds where we can determine what's the right level of confidence to have for a particular application. For this, we get insight from our customers. So we run a process that we call matched pairs, where we can get individuals who we're working with to deliver a specific application to actually look at pairs of records and give us their judgment about whether that is likely to be a correct match or not. We can compare that kind of ground truth on quality of a match to the scoring coming out of our algorithm, and we use that to set appropriate thresholds, which can vary depending on a particular application. Sometimes you'll have a tolerance for a lot of false positives if you know that is going to be subject to manual review before you actually make any intervention or take any action. Sometimes when you're looking at a much larger population, you want to be absolutely confident that you're going to have very few false positives in that set. And we have that flexibility to kind of turn the dial up and down. Matching itself enables a whole load of valuable products that we can deliver to the department. So for instance, enrichment, this is a common scenario when we're supporting operational colleagues who will have a list of individuals, say, who are of particular interest. They want to know more about these people. What do we know across the immigration and policing and crime data sets that we hold that can support them as they investigate these individuals. And also search. So there is a large group of intelligence officers within the department, both supporting border force but also immigration enforcement. We can support their work by providing them with a tool where they can search for an individual that they're investigating and then explore out through that graph to look at other individuals associated with that person through shared addresses or other association types. So there's two kind of data exploitation products that we offer, but I'm going to go into a bit more detail on a couple of machine learning projects. So kind of micro introduction to supervised machine learning. Supervised machine learning is about using historic data, labelled historic data, so we know an outcome or other variable that we're trying to predict for a bunch of historic cases or instances, and want to predict for future cases, for new arriving individuals, what do we expect the outcome for that person to be. And the approach taken turns kind of traditional software design and perhaps traditional OR-type modelling on its head a bit. So this isn't about handcrafting of an algorithm to come up with a prediction. It's more about the data scientist kind of setting the conditions, getting the data into the right form and selecting the right algorithms that can learn from this data and come up with a predictive model. So general approach, we've got source data at the top left here. We create feature vectors, so this is about crafting many variables from that source data that we think may have some predictive power for the outcome we're interested in predicting. We have the combination then of those feature vectors and labels, so the known outcomes from historic cases that we can feed into the machine learning algorithm and get that to explore the solution space and find a predictive model, which is then what we use for the kind of execution side of this, which is of course about taking new unseen cases, running them through that predictive model to find to generate a prediction. There are many different algorithms for doing machine learning, but they all fit this kind of overarching model. And I'm not going to go into the detail of each of these, but of course it's part of the skill set of a data scientist of identifying what is the right algorithm to use for the data you've got for the particular problem you're trying to solve. Another area where the data scientist skill kind of comes to the fore is about monitoring how that machine learning algorithm is tuning itself to the data. You don't want to underfit on the left, where it seems like there are patterns in the data there that the model, the blue line, is not perfectly capturing. We think the model could do better, or the feature vectors that we're providing to the algorithm to learn from could be better crafted to capture some of that, the underlying associations there. On the right-hand side, you also don't want to have a perfectly predicting model for your training data set. You don't want to overfit in that way, because the concern would be that when that new kind of unknown data is passed through your predictive model, it's no longer going to generalize to the unseen case. So this is where the kind of skill of the data scientist comes to the fore, not in the kind of handcrafting of the model itself. It's more about real focus on how do we properly articulate the target variable, the thing we're trying to predict. How can we identify potentially valuable features? I say potentially because we give that job to the machine learning algorithm itself to work out which data items are of importance. How do we measure success? i.e., what is the optimization objective that we give to that machine learning algorithm? What is the right machine learning approach to set running the algorithm choice? And how do we go about tuning exploring the hyperparameter space, exploring twiddling the knobs, I suppose, on those machine learning algorithms to allow them to find a good fit for us. Of course, we've also got great dependencies on data availability. Generally speaking, the more historic data we can lay our hands on, the better. And some of these techniques are really computationally intensive, so being able to leverage and scale that computing resource. So I don't think this is a recent photo of a visa caseworking set up in the Home Office, but it does pull out some of the challenges around visa casework, which are very high volumes of cases. We processed about 3 million visa applications last year. The majority of those will be visitor visas, but there's a whole range of different visa types, including people who will be applying on a kind of family or HR human rights basis, these are kind of more complex cases that will generally have a lot of case history to them. You can see from the size of some of those document packs there the kind of depth of evidence that is attached to each of these more complex visa types. And also one of the challenges for the Home Office around getting rid of some of this paper and kind of making changes to our digital systems to work in a more modern way. This case study focuses on those family and HR, the more complex application types, where we have about a 50% grant rate currently. And we have, across the board actually, caseworkers considering each and every application. So it's still humans who are making these decisions about whether a visa is granted or refused. And we're not changing that through machine learning. It's more about how do we support those caseworkers. So the model we developed for this visa route, the chart on the left is the reds and the greens are grants and refusals, and you can see the kind of predictive power there. So across the bottom from left to right is the score that we gave individual cases, and the reds and the greens are the actual kind of outcomes from this holdout test set. So this is the actual outcomes from these caseworker decisions. So that's a very pleasing pattern. We're able to set thresholds there, the two verticals, which identified 3 pots, the greens, the ambers, and the purples. The greens being cases that we are very confident are going to be granted, the purples ones where we think this is a likely case for refusal, and those in the middle which where we're the model itself is less confident. On the right-hand side, you can see the kind of number of features that we explored, so the candidate variables that we fed into this model during the training cycle. Actually, there were more than this. I think we got up to 250 or odd candidate variables, but you can see there's a real elbow to this data where we're getting a lot of the predictive power from the first 20 features, which is what we used for our deployed model. This is a model that's now in operations. It's being used by caseworkers. In fact, they've changed their way of working, so they now have green, amber, purple teams who are kind of specialising, i.e. you've got more experienced caseworkers tackling some of those more complex cases, a bit more scrutiny perhaps over some of those cases that are likely for refusal. And we've seen some increased throughput from those teams as a result of that specialisation. So it's still individual caseworkers making that final decision, but we've got this streaming element now up front, giving cases of a similar type or similar likely outcome to those specialist teams. So thinking a bit about our experience in actually deploying that model and kind of what happens next. On the left here, you've got a chart showing the distribution of cases over a period that were scored and given to the caseworking teams. On the right-hand side, you've got the outcomes that were decided over that same period. Do you see any pattern in that data at all? Obviously, we're still pleased to be maintaining that kind of level of quality, the kind of high level of grant decisions on the left, high level of refusals on the right. This is an interesting effect of introducing this new change. They aren't processing the amber cases, essentially. And it's interesting kind of discovering this as we're getting into more kind of further towards really embedding and operationalising some of these machine learning models. The case that it can't be a matter of just kind of deliver and deploy and kind of walk on to the next project. It's got to be a kind of ongoing process of monitoring these models in deployment and working with the customers on how they're being used. The case here is that the caseworking team obviously want to clear backlogs. They're prioritising the greens and the red cases, which they think they can process more quickly. This is terrible feedback loop for us, and we changed it since. Because it's also those amber cases in the middle which the model is finding it hardest to predict on. We need outcomes. We need the insight from the caseworking team on these cases in particular in order to refine and improve our model. And of course, there's also the risk to individuals who find themselves in that pot. I should say on that last one, there's also an issue here of kind of the dog eating its own tail kind of problem. You know, we've trained a model based on caseworking decisions that we are now using to give some guidance to caseworkers as they make decisions. You know, are they going to start trusting the model too much? This is a risk that we need to deal with. So we mitigate that in two ways. In fact, you could say that the amber group in the middle is part of that mitigation. You know, we're being very clear where our confidence is not as high, and labelling those appropriately for an extra level of scrutiny by caseworkers. We also have a process where we randomly shuffle cases. So within the green pot, we'll slip in some purple cases and vice versa, so that we can monitor the relative decisions that are made by those green and purple caseworking groups. So we can be on top of, okay, is there any bias emerging here? What's the risk, and how do we work with those caseworker management teams to make sure they've got the appropriate level of scrutiny and challenge around them? Another kind of reflection on what happens when we get these models to deployment is the new dependencies, the new kind of business critical dependencies that suddenly get created. The snapshot on the left there is our interface for this model. It's very basic actually, and that reflects our kind of interface of this new model that we developed with the reality of caseworking at the moment. How the caseworking management team use this tool is that they'll say, give me the green cases from the last week, give me the ambers, give me the purples. We'll provide them with a long list of cases, and then somebody will go and collect these files and put them on the green shelf, the amber shelf, the purple shelf. That's the reality of kind of how this model is interfacing with our current ways of working. Of course, there are other developments going on right now to transform that way of working in itself. So ultimately, we're designing towards a solution where really the model itself kind of disappears for caseworkers, and it becomes an input into an electronic case management system so that cases can be automatically routed. Related to that change are changes to the front end around data capture, and in fact changes to the data system itself. Of course, this is really critical for us because we've got a model that was trained on data at a point in time. Suddenly there are real dependencies because the caseworking teams have reorganised themselves to be using the outputs from our model. It's important that that model maintains its predictive power even when methods of collecting data change. So we've got real interest in making sure the data that we're critically dependent on is still collected, that we understand how it might change, and have got monitoring in place so that as those changes come on stream, we can react accordingly. Quickly on what makes this a good model, and the predictive power of this model is good. We're very pleased with it. Nice balanced classes, roughly equal amounts of refusals and grants, really rich data because we're talking about cases that have got a lot of history to them, individuals who exist across our data systems, and also fast feedback loops. We can quickly capture the real grant and refusal decision and use that to analyse the performance of our model. Some other things we've done on the back of this work, we've been developing a machine learning framework code base that we can use for other projects, and this is a very repeatable problem for the Home Office, which has got a big business in looking at cases and awarding status. Potential to also reuse some of the features that as inputs to other models, and also thinking about how would we standardise our monitoring of performance of our machine learning models across the board. Some alerting to make sure we know and can alert operational colleagues when the predictive power is going awry, for instance. Second case study, analytics at the border. Bit of context, 140 million passengers enter the UK each year. Most of those, some of them will have been through a visa application process already, but a lot of people crossing the border, there's lots of British citizens coming home, of course. There's also people arriving from non-visa countries where there's no requirement for them to apply for a visa in advance of travelling. Of course, you've got the EU, who have got freedom of movement. We still have 100% checks at the border, so you'll always either be, you'll have some interaction, whether it's with an e-gate or with a border force officer. And of course, an interaction at an e-gate can lead to you being routed to talk to a border force officer. The vast majority of people crossing the border are completely compliant, but we have got quite a wide range of threats and vulnerabilities. But it's also a very kind of powerful, potentially very powerful intervention point. Everyone who enters the country goes through this interaction with a Home Office officer. There's potential to intervene there for the right problem. We also have limited notice of arrival. So we may not know if you're traveling, it depends on what mode you're traveling by, but the window between us being notified of your intent to travel and you actually arriving can be quite short. But we do know, because that kind of advanced passenger information that you always fill out when you travel, you enter your name, your passport number, and so on, that is a stream of data that we can get hold of. And it is streaming, so this is a project about dealing with streaming data and how can we provide analytics at the time that it's needed. So you can consider this kind of journey to the UK border. You've got the person travelling, but you've also got this kind of data journey, that API trigger, advanced passenger information trigger, that gives us that kind of window of opportunity in which we can perform some analytics and provide some kind of alert to the front line at the UK border. One of the scenarios we're looking at here is modern slavery. So can we identify individuals who are potential victims of trafficking at the point that they're entering the country? So this is a huge and very harmful problem. It's one of the top priorities for the Home Office. It's estimated there are about 13,000 victims of modern slavery in the UK. A large proportion of these will have crossed the UK border. Okay. But on the challenging side for us as data scientists, it's a very imbalanced data set. Of course, the vast majority of people crossing the border are not of interest, at least in the context of modern slavery. We also have very long feedback loops. So what I mean by this is that people, even individuals themselves as they cross the border, may not be aware that they're potentially a victim of trafficking. It's very challenging for the Border Force officer to identify that as a potential risk at that point. So it's hard for humans, but there's potential here for machine learning to have an impact. One thing machine learning can do is, because we've linked up this data and we have indexes of identified victims of trafficking in the UK, we can design algorithms that can learn over this much longer timescale. And it feels like networks could be important here. So if we can identify individuals who have an association with a known trafficker, with another victim, this feels like something that could give us some predictive power in identifying other vulnerable individuals. And of course, that's hard to do without this kind of approach. What we've seen is there's been a lot of focus in kind of building that first model, iterating, adding more features to the model, continue to try and drive up that predictive power. It's very different to the visa caseworking instance. In visas, we were interested in the predictive power across all of the visa applications. Here, it's more about how do we make the very best use of the limited resource that we've got to focus on this. So in conversation with our customers, we looked at the potential number of more detailed checks that could be carried out each year. How do we focus on really improving the number of likely victims that we can identify at that recall window? I'm going to have to skip over this very briefly, but the point to make is there is a complex infrastructure that is needed to support this development. So focusing on how do we stream data through, how do we bring together data that will be working or kind of arriving at different paces, that kind of merging of the fast-moving data from advanced passenger information with the more slow-moving data from when we've encountered these individuals in the past. And a whole mix of different technologies that we've ended up deploying to support this work. And that's been one of the challenges of the project, really, this pilot project, is how do you work in an agile way alongside all of those data and digital professionals who need to figure out all of this stuff in consultation with us, while also agilely developing the predictive model. And how do you make sure that the data science bit doesn't get squeezed at the very end of the project? How do you make sure that you're building the kind of predictive power of the model all the way through the project duration so that you can deliver a valuable product at the end? So outcomes from this work, we did prove our ability to provide real-time scoring or near real-time scoring at the border, and to do it at scale, to actually be generating such predictions for all arrivals into the UK. One of the challenges, as I mentioned, kind of how do you pair up agile software and platform development with doing agile data science? Also, a continuing challenge for us is how do we really demonstrate success in these kind of scenarios, where success may be going from a random targeting regime where you'll identify the kind of 1 in a million victims of modern slavery as they cross the border, to a predictive power of a model that may be 100 times better, but it's still identifying 1 in 10,000 as a potential victim. Difficult to demonstrate that success and build the kind of confidence of the customer in that work. Need for fallback models. One learning from this is where you've got that really complex infrastructure, you can't rely on it operating at 100% of the time. We needed to build simpler models that we could fall back to. If one of our data streams gets delayed, or isn't able to arrive within the window of opportunity when we need to make a prediction, can we fall back to a model that has some predictive power but doesn't draw on that particular data set? And the infrastructure is hard, so this really needs to be a suite of projects where we can look at, okay, we'll tackle one harm theme, but where else can we also add value by sweating that asset, if you like. Last slide, quick reflections on doing quality data science in government. I used the term a couple of times over those last couple of slides, agile. We work in following agile project management methodologies, kind of short 2-week sprints, trying to be continually adding value and delivering minimum viable products. I think for me, some of the key things to making that work are making sure we always have a question. It may not be the same question that we ultimately want to answer, but always have something which is guiding the kind of data science exploration work through those short sprints. Always be thinking about the customer, so we work having product owners, customer representatives embedded within project teams, which is invaluable for those kind of quick question answering and making sure that we keep on track and really kind of answering the customer need and supporting that, kind of creating outputs along the way. How do we need to make sure that we're constantly sharing insights from the data science exploration. Quality assurance, we have processes where we have QA reviews at key stages of all of our product releases. For business critical models, there's also a big focus on this across the department, and we have independently chaired analytical quality assurance board at which we present key work. Making time for innovation, so within the lab we're lucky in that we've agreed to preserve kind of 20% of data science time to focus on more innovative work. So work for which we may not yet have a customer, but we have a customer in mind. And how can we expand our product offering by trying out new techniques that we can work with our business analysts to offer to customers as services for the future. Focusing on consolidation and reuse of our code base. And always creating opportunities for us to share knowledge. So we have regular knowledge shares within the team. We also have our kind of extensive Wikipedia-like resource within the lab, which is the kind of default location for outputs that we generate during data science work, and we make that shareable across the entire team. Focus on auditability and fairness. Fairness in particular in machine learning is a key issue for anyone working in this field, I think. It's certainly centre of our minds at the moment, but we're also very keen to be looking at good practice that is emerging across the field here. Proving our benefits. Sorry, I'm about to be yanked off. I had a section here about skills. My main message here is that almost all of the data scientists in my team have come from an operational research background. I think there's a kind of such a strong overlap in the skill set and mindset, really, that people coming from an OR background can really apply to data science. But it's not just that skill set. It's also a kind of strong focus on software engineering and driving innovation. These are the 6 headlines of the performance framework that we use in my team. Yes, and one of my preferred quotes about what a data scientist is. Thanks, John. Sorry for overrunning.
Thank you very much indeed, Rupert, for that.